Hi everyone. Today I'm going to explain the paper that is Bi-Mamba towards accurate one-bit space models. Coming to the initial motivation, the growing size and resource demands of the state of art large language models and transformers pose significant challenges in terms of computational costs, memory footprint, carbon footprint, and energy consumption. While state space models, SSMs like Mamba, address the inefficiencies of the transformers by offering linear computational complexity and reducing memory requirements. So, the problem of the resource intensive training and development as the development persists, there is a we have to tackle these challenges on getting of a new models for reducing the memory footprint. So in this paper, Bi-Mamba is introduced, which is a scalable and efficient one-bit version of Mamba architecture. The goal is to leverage extreme quantization to maintain high performance while drastically reducing the energy consumptions, memory usage, and storage costs, thereby improvising more from the current state of our transformers as LLMs. See, from this graph, you can clearly see that perplexity is very low for the current architecture compared to the other GPT-QI by LLMs. As lower the perplexity, the best is the model. Coming to the introduction part. So, large language models have revolutionized NLP by achieving remarkable results across various tasks. However, their computational complexity and memory requirements remains a bottleneck for the scalable training and deployment stages especially in the resource constrained environments. Stage-based models like Mamba has emerged as an alternative to the transformer, offering linear complexity and reducing memory demands. Yet, the potential of the extreme quantization, specifically like one-bit representation for SSMs, remains largely unexplored. This paper presents Bi-Mamba, the fully binarized Mamba model, which is designed to achieve competitive accuracy with a significant smaller resources footprint. By employing binarization-aware training, Bi-Mamba ensures effective quantization while preserving model performance. Extensive experiments has demonstrated that it has a potential to advance to the design of efficient LLM tailored for the specific specialized hardware. Introduction is done. Coming to the background and related works. So there are two types of quantization. Post-training quantization means quantizing the model after the process of training. With the quantization aware training means introducing the quantization during the process of training. Like quantization aware methods is more preferable compared to the post-training quantization because we are training in the process of training so that the model get adapted to the data set and it gives the better performance. Background, unrelated works. Transformers have become the dominant architecture for the LLMs, but their quadratic complexity with sequential length pose several limitations for the long context processing. State-space models like Mamba 2 provides an alternative with the linear complexity and constant memory requirement during the inference. These models have shown superior performance for tasks involving extended context. Quantization has emerged as an effective solution to address the high computational costs of an LLMs, with prior work focusing on reducing transformer models to 8-bit or 4-bit representations. However, However, these methods often fail to retain the performance of at 1-bit precision, particularly for SSMs. Bi-Mamba bridges this gap by introducing binarization-aware training, enabling efficient binarization of Mamba while preserving the performance, thus paving a way for scalable and resource-efficient LLMs. See, here is the architecture of a Mamba 2 block. And we can clearly see that ultimate outputs and inputs will be in the range of will be 1 or -1. That's called binarization. And from this graph, plotted for full precision post binarization aware quantization, it is observed that post binarization distorts the weight distribution, leading to a poor model performance. Binarization aware training mitigates this issue by gradually training the weights into a binary compatible form, preserving performance while achieving the benefits of extreme quantization. This demonstration suggests that binarization aware training is a superior approach for 1-bit weight quantization compared to the native post binarization methods. Coming to the approach, to effectively binarize the Mamba architecture and maintain the competitive performance, By this architecture is proposed. It is a framework that employs binarization-aware training for the one-bit quantization. What is binarization space identification? It means the Mamba 2 architecture comprises of several components embedding layer normalization, delta bias, state space matrices A, B, C. The convolution layer, input projection, output projection. The analysis of this parameter distribution shows that input and output projection matrix dominates the overall parameter count, accounting for over 90% of total parameters. Embedding and causal head parameters are excluded from this binarization to retain the token semantic representation. This is one thing we have to note. Coming to the methodology part, Bi-Mamba applies binarization-aware training to the Mamba architecture by identifying and optimizing specific components of model for extreme quantization. It is going up to 1 bit. It is 1 bit stage. The approach focuses on the input and output projection matrices, which constitute the majority of the parameters in the Mamba models. The binarized weights are represented as a binary matrices scaled by learnable factors, ensuring robust performance through auto-regressive distillation loss during training. Auto-regressive distillation means training by taking a teacher model, getting insights from the teacher model. A straight-through estimator approximates gradients for non-differentiable binary optimization, allowing effective backpropagation. The models are trained on a large-scale datasets using teacher-student distillation. That is what I was saying. Where high-precision teacher models guides the learning process, this ensures that, like Bi-Mamba, maintains the competitive performance across large language modeling and downstream tasks, even in its fully binarized state. I guess by this time we are all you people are all aware of the binarization, aware training, and post-training binarization. Coming to the training and evaluation. The models are trained on an AMBER dataset using an autoregressive training strategy. Bi-Mamba is trained on multiple scales, 780M, 1.3B, 2.7B parameter models, and evaluated on the perplexity metrics. Wiki text 1, PDs, PTB, C4, these are the language modeling datasets, and zero shot downstream tags like Bulky, Hello, Swag, ARC, and Vinogrande, etc. Okay, coming to the results. So coming to the performance comparison, it is observed that the Bi-Mamba achieves a competitive downstream accuracy, closely matching full precision Mamba 2 models while outperforming baseline binarization methods such as GPTQ and LLM. Across model sizes, 780M, 1.3B and 2.7B. Bi-Mamba consistently surpasses the post-training quantization and binarization methods in both zero-shot downstream accuracy and the perplexity metrics. Coming to the perplexity metrics, Bi-Mamba reports substantially lower perplexity scores compared to the post-training binarization methods like GPTQ, 2-bit LLM models such as Wikitext, PTB, and C4. In some cases, the fully binarized Bi-Mamba achieves perplexity scores lower than the full precision models, indicating the binarization aware training preserves linguistic coherence. Efficiency gains. Bi-Mamba achieves a storage compression ratio of over 85% with full binarization, and it drastically reduces the memory requirements without substantial accuracy loss. Coming to the training dynamics, the training process has shown rapid improvement in the perplexity at the early stages, demonstrating the effective binarization aware training in the preserving model capabilities. Bi-Mamba's convergence tends to indicate that the model can achieve optimal performance with additional training, highlighting its robustness and scalability. These results validate the like Bi-Mamba as a scalable and efficient alternative to traditional LLM architectures, capable of maintaining performance while addressing the challenge of memory, energy, and computational constraints. This is all these results are about, and we can clearly see that Bi-Mamba has outperformed all the outcome from all the state of particles except the full precision. It is nearer to the full precision. But we have achieved a model which with less memory footprint and KV cache storage. These are all analysis about yeah model parameter storage and compression ratio. We have achieved up to 89% for Bi-Mamba full binarization. Coming to the conclusion part. This study introduced Bi-Mamba, a novel one-bit binary state space model architecture designed to tackle the resource-intensive nature of large language models. By applying the binarization away training to the Mamba 2 architecture, Bi-Mamba achieves competitive performance comparable to the full precision counterparts, while significantly reducing the energy consumption, memory usage, and storage costs. This study highlights the potential of one-bit SSMs in enabling more sustainable and accessible LLMs, while also opening avenue for hardware acceleration tailored to one-regional models. This work serves the foundation for future research on efficient low-bit models that balance performance and scalability. So improvements can be like we can basically reduce the size still further, or like we can add the interpretability as a topic to the state space models, which is what I'm currently exploring. For sure I will make the video if I get to know any conclusions or good results. Thank you, thanks a lot.